I loved alpine climbing, ice climbing, skiing, hang gliding. I did all these ridiculous things and managed not to kill myself. It was an amazing time, Brad, but there also comes a time when you're doing stuff like that. You do realize that there's an expiry date on doing this kind of thing.
Very excited for the podcast today. We're going to welcome David James. Welcome, David.
Welcome, Brad. Thank you very much.
So, David is the CEO and owner of Create and Construct Scottsdale and also Exquisite Wine Cellars. And I've known you for quite some time now, David, especially through social media, and we've connected for a while. And there's a lot that you're going to have to share with the audience here. So, I'm very excited about it. So, thank you for making time today.
Yeah, you're great. You're very welcome.
So, let me start here. CERN,
Yeah.
CERN.
hmm
I want to understand about CERN and kind of how that relates to the complication of CERN to what you're doing now today.
Okay, so just a brief history on CERN. So it was founded in 1954 by what was called the member states, which were originally four European member states, and it's expanded today. I think there's currently about 45 member states in it, and there's about 120 countries that participate. So it was originally based in Switzerland, and then what happened was, as it grew, as the laboratory grew and grew, it actually spread into France. So it's actually counted as an international enclave, which is quite interesting. So when you're driving around the CERN site, you actually cross the border between France and Switzerland all the time. So you've got two main sites, and then what they do is that it's high energy particle physics. So they're looking for what they call the fundamental building blocks of the universe. What happened immediately after the Big Bang, and this kind of stuff. And it's grown into probably the leading laboratory in the world now for this type of thing. And what they do is, there's so much that goes on at CERN. Nothing involving black holes and this kind of stuff. It's everything that happens at CERN is public knowledge. It's all put out there on the internet, and it's actually where the internet was invented by a guy called Tim Berners-Lee, who he developed the internet. It was an idea. It was a way of so physicists could share knowledge between themselves at anywhere in the world. And the first internet server is actually on display in the computer center at CERN. And it's a little Apple server about this big. So but that was the first. That was the first internet server. So what they do is there's two parts to the experiment, if you like. You've got the accelerator, and then you've got the actual experiments themselves, which are detectors. And if you can imagine, it's quite hard to conceptualize. And before I actually went there and worked there, it's quite hard to get your head around. But if you can imagine a 20-mile circumference tunnel underground in a big circle, it varies between about 400 feet and 600 feet under the ground, depending on the relief where the mountains are and everything else. And then you've got four main access points. So these are shafts that are sunk down into the tunnel. And then you've got what you call the experimental caverns dotted at these 4 points around the ring. And the caverns are typically, the largest cavern is again about 400 feet long, 150 feet high, and about 150 feet wide. So you can imagine that these are basically a cavern that's built in the earth. They were dug out of the earth and excavated, and in those sit the particle detectors. And what they do is the machine, the LHC, the Large Hadron Collider. What this does is they inject hydrogen molecules into the actual beam line, and they accelerate these with what's called radio frequency cavities. And the idea is that they accelerate these particles to just fractionally below the speed of light. So if you can imagine, they are orbiting the ring 11,200 times per second. So that's the actual speed that they're traveling. So they're traveling around this ring 11,200 times per second. And what they do is they have a positively charged particle and a negatively charged particle. And with magnets, they steer them together and they collide them in the center of the detectors. And then what happens is you get what's called an event, and the event throws off billions and billions of subatomic particles. And these are actually picked up by the detectors. And these events last for fractions of a millisecond. They're absolutely like fractions of a millisecond. And what happens is they can tell what the particles are dependent upon the their direction, their trajectory, their speed, and everything else like that. And then they know, and these are logged. And when we built the Atlas detector, which was the one that I was primarily involved with, the uh, cables to carry the data hadn't yet been uh, built, or they didn't actually exist, because that level of data, the amount of data that they used to transfer, they hadn't actually been made at that time. But what happened was, they said, yeah, well, we look at it now, we're at 2001 here, and then by the time we get 2008, they will have come up with that technology to transfer all the data. And of course they had done. So I mean, the amount of data that's thrown out it's kind of equivalent to everyone in the world speaking on a phone 20 times over per second. That's the kind of that's the level of data that you're dealing with, that is produced by these collisions. So it's really quite staggering stuff, and to get your head behind how big you have to go to find the absolute smallest particles that are known to man. It was really a very, 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 very interesting experience. And I mean, there's so many things to talk about at CERN. What they do, and the spin-offs from it. There's a lot of medical health, spin-offs that have been created as a result. For example, we built superconducting magnets. So what you have is, there's a phenomenon called superconductivity. So as as an electrician, Brad, that you can only pass a certain amount of ampage through a cable before you'll actually melt it. There's too much resistance, and then it melts. But what happens is, with electrical cables and a certain type, if you cool them to absolute zero, which is minus 270 degrees centigrade. Don't quite know what that is in Fahrenheit. You have to excuse me on that one. But it's somewhere around there. But yeah, what happens is all molecular activity stops, and then you get this phenomenon called superconductivity. So through a wire that's like a 16th of an inch diameter, you can pass 4,000 amps. So what that means is that you've suddenly got this very, very compact magnet with a phenomenally high output. But this has to be super cooled. It has to be super cooled. So this is done with helium, and what happens is the magnet is cooled, and then you can start to increase the amperage as it comes down to absolute zero. But the problem is with this is that all of the wires must be absolutely immobile, and they have to be encased in a resin, because if you get the slightest movement in there, this can create a heat spot, which actually causes the magnet to come out of superconductivity. It's what they call a quench. And if, as you can imagine, you've got 4,000 amps going through a cable 16th of an inch in diameter, suddenly that just turns into a huge oven, and it would just destroys it immediately. So they have built into the magnets, they have something called a quench detector. And if they detect a quench, these things happen within milliseconds. It's so fast. Then what happens is the power is immediately shut off to the magnet to save it. And bear in mind that we installed in the LHC, we installed 1,643 cryodipoles, each at a cost of $1 million each. So you didn't really want those to melt down too often. It would have been quite an unfortunate experience. So there were so many things that we did. It was fascinating building the actual cavern for Atlas. What we did was we sunk 2 shafts, and then we built the roof vault, and we suspended the roof vault on cables, and then we dug down as we actually built, we built the cavern, and the floor of the cavern had to support the experiment, which weighs about 7,000 tons, and the floor was actually about 15 feet thick with rebar spaced probably around every sort of 4 inches or something like that. So I mean, it was just an absolutely solid mass of concrete, that had to be perfectly level, perfectly plumb. And we had to take into account, when we built the experiment, we had to take into account that because we dug out the cavern, the ground above the cavern floor was relatively light. So what happened was the floor was actually going to move up at about a rate of about 1 millimeter a year. So we had to dial into the feet of the actual machine, the experiment. We had to be able to adjust those so that the machine can come down as the floor comes up during the lifetime of the experiment. So it was built. Atlas was built to look for what was called the Higgs boson particle, and this was theorized by a couple of physicists back in the 60s. And it's what they call the secret of mass. So it's to do with why objects have weight. You know, why do things actually weigh something? Um, and it was really very sort of rewarding to see that when they did turn on the LHC, all of the indications that had shown about the Higgs boson actually came true, and they did discover the Higgs boson particle. So almost, what was that? Almost 50 years after it was theorized, they did actually. It was the one piece that was missing in what they called the standard model of physics. You know, they'd never actually been able to demonstrate it, and you needed very very high energies to create to recreate the Big Bang, to actually split the particles down to small enough, small enough components to see what they were. So they did find the Higgs boson, and yeah, it was a, I just saw it as a job while I was there. I mean, I was what was called a work inspector. So I oversaw all the subcontractors. I was responsible for subcontractor selection, and we traveled all over Europe because it was a collaboration between about 120 countries. So we traveled to Italy, to the Netherlands, to Germany, to France, to select the subcontractors. And it was, it really was. It was a fascinating experiment, if you like, in terms of collaboration and you know, getting along with people, culturally learning how people work, how they don't work, how to explain things. So that really was fascinating, and I've taken that away from me from my time at CERN, because it was a very very interesting environment to work in. Sometimes frustrating. There was so much protocol with regard to, oh well, you can't do this because Italy might get upset, or you can't do this because the Germans won't like it, or you can't do this because the Brits haven't put enough money into this or something. So it was this whole game of conjuring all the time. But that, again, it makes you resourceful. That's the thing. It really does make you very resourceful in how you operate. So yeah, interesting times. Almost, what will it be? Hang on, it will be almost. Wow, it's almost 30 years 28 years since I started at CERN. That was 1996. So time flies when you're having fun.
Well, David, I mean, there's a lot to unpack here. I think what's interesting, if I'm not mistaken, was it Angels and Demons? I think that movie was
You
essentially
got
Cove,
it.
right? Yeah,
And that was the Atlas experiment. That was the it's
yeah. Because when you're
it's a very
speaking
good.
about that, it reminds me exactly of Angels and Demons, the movie, in the book and stuff.
Well, that's it, because when it's a very accurate representation of the Atlas experiment, except that I think you see in one point, like they're looking through the control room window, and then the experiment's just outside next to you and so on. I mean, it's absolutely nothing like that at all. The actual control room is up on the surface, and no one is underground, because there's very very high levels of radiation, but they have an extremely short half life. So they shut down the experiment and the accelerator, and within a couple of hours it's completely safe to go in there. So it's not there's no the only areas that have got a lot of lasting radiation is what they call the beam dumps. So what they do is um, when they've finished with a beam, if you can imagine, the beams are like two clumps, they're like two clouds shooting around two tubes. You've got two tubes that are in a perfect vacuum, and these clouds are moving like this. And what happens is they steer them together with the magnets, and then they collide them. So you'll get a few collisions every time these clouds pass. But when they're done with the clouds, they have to actually dump them. They have to get rid of them somewhere. And the beam dumps are. It's almost like, if you can imagine, like a railway track. They're directed off, and then they're dumped in. Now the beam dumps are basically solid iron blocks, and there's about roughly, they're about 100 feet long by 20 feet by 20 feet square, and it's just a solid mass of iron. And they shoot these beam into these things, and then this dissipates the energy. But it's like the equivalent of crashing a freight train into a brick wall. That's the amount of energy contained in the beams. So they have to go somewhere. And we originally installed cameras in these things and cranes, because you have to move the blocks. This is all underground. This is all about 400 feet underground. and we had to move these iron blocks in. And once they actually started, firing beams into them and so on, then the camera and the crane and everything else lasted. I think it was about 2 weeks. I mean, the radiation just absolutely destroyed it. So, they've still got to get those blocks out, but I'm not there anymore. So I was only paid to put them in. So that works fine for me. That's fine.
Don't have to work on the demo crew. Well, let me ask you this, David. What's interesting about um, your history there? So you mentioned where you involved is subcontractor selection, right? You're scouring Europe to find some of the best trades. What
Yeah,
what went into that evaluation, and especially it sounds like not so much from the scientific side, of the the scientific experiments that are happening there at CERN, but you're working on the actual construction of the lab, right? What
yeah.
what what did that entail for you to really, um, investigate these subcontractors, make sure they're qualified because of the precision that has to go into the construction?
Yeah, it was a very it was a complex procedure because CERN put out a very detailed criteria for what was required of subcontractors, and you know every subcontractor that you met could, of course, fulfill all of these terms and conditions. Of course they could. That wasn't a problem, and they did then obviously take the lowest bidder. So in theory, it's kind of like going to the moon. They went to the moon in the lowest bidder, which was the, so it's kind of a bit like the same thing, really. We carried out, we would always go and do a site visit, and go and check out their current working conditions, how they worked, what they did, what their organisation was, how they organised their crews, because CERN had also got very very strict criteria on the personnel that were allowed to work there, not for any security or safety reasons, other than everything had to be absolutely above board. Every person had to be accounted for. Every person had to be legally allowed to work in the country where the subcontractors were from, and so it was very complex. The Swiss, because they were also working on Swiss soil. The Swiss have got a lot of criteria that they put in place as well for work permits and so on. So you had to make sure that everyone that came onto the site was an absolute bona fide employee that had the right to carry out the work. So we would go and visit the sites. We'd talk a lot with the management, and it did also, Brad, just come down to a lot of gut feeling. You know, could you trust what these people were saying? Were they really interested in a partnership as such, or were they just interested in coming to work at CERN for their CV? There are a lot of things in the mix, and we had one subcontractor, who talked the talk very very well, and they had a very very good background and everything else, but it's unfortunate to say as well that they were actually an English company. They had recently bought one of the oldest moving companies in the UK, which dated from like the 17th century. It's a company that's been around for literally centuries, and they'd recently carried out a takeover of this. So we thought, yeah, they've got a good background here and everything else, and they were trying to run it purely for profit. And it just didn't work. They stuck it for about 12 months, and then they actually pulled out because what they said they could offer and what they were actually able to offer were two very very different things. So that you're not always right with these things. You're not always right, but it was a real learning point, and this is why I do feel that of course you've got to look at the company structure. Of course you've got to look at the operations, the history, and everything else like that. But there's a large part which is just gut feeling. I remember interviewing another company. It was actually a heavy handling and lifting company that we used. And when I asked, I said, how are you going to manage this? How are you going to roll this out? How are you able to actually do this? And they just said, we can do this. It's okay. We can do this. And I said, well, sorry, but that's not good enough. I need something a little bit more concrete than this. We're about to embark on a $12 million annual contract, and we need something a little bit more concrete than we've got this. So it was very, and again, culturally, it's very interesting. You learn the subtleties of so many cultures. That is just, it's fantastic. It really was a heck of an experience. So yeah, that was, that took place. That would have been about early. Let me think now. That would have been about 2001. I think we were selecting a lot of the subcontractors. And they got signed. But you're often talking that they were going to be moving in personnel, often 150, 200 men to come and work on the site, because these were huge civil engineering contracts. I mean, these were really big things. We're not talking about five guys in a van. I mean, it was, in some cases, it was a company moving their entire company to come and work and live in Geneva, whilst they carried out the work. And it was interesting because some sites were in France and some sites were in Switzerland. So, you fell under the Swiss building code and regulations in some sites, and then you fell under the French building code in the other sites. And you had to deal with two sets of inspectors who had both got their own agenda. And, all the health and safety guys, the OSHA crews. We actually had our own in-house OSHA crew, a guy called John Etheridge. Now, John had played professional rugby for Ireland, so John was about 6'6", not quite as wide as that, but almost. And he had hands like shovels. And John was the nicest guy you could ever wish to meet, unless you had a health and safety infraction. And John's usual technique was to sort of get very close to someone, and then sort of look down at them like this, and say, "Okay, Pedro, well, that's not going to happen anymore, is it?" Like this, and there was this sort of frantic nodding of like, "No, no,
Yeah.
no, John, no, I understand. Yeah, okay, we've got it. Fine, won't happen again." And John was an absolutely fantastic guy, and yeah, he's still there. He's actually still there. He's still working in health and safety. So, but he was the best health and safety contravention deterrent that I think I've ever met. So, that was compliance was top of everyone's mind when John was on the site. So it worked. It worked
Well,
very well. It's very
what's interesting is when you're working on, an industrial project, wastewater, it doesn't matter, high rise building. I mean, safety compliance is number one, right? Because,
yeah,
um, life and death is a real thing. It happens on projects, right? And that's one of our biggest concerns. I think any builder, right? No one wants to have anyone severely hurt, injured, especially pass away on the job site. And you have to have someone like that, on the project. And to me, a lot of this stuff, David, in fairness, I mean, you're saying it fairly lightly, but all of us that have built know how complicated this is, right? It's one thing to be vetting
yeah,
subs from Ireland to the Netherlands to Spain, or, all throughout the Eastern or European area that you're negotiating the subcontracts. But, just similar to like US, when you're paying someone to go remote and build these massive structures and you're paying per diem, what did that look like? I mean, because part of this isn't just the contract, but you're trying to, as you mentioned, you have 150, 200 people. It sounds like just with the shoring and rigging or the civil company, I mean, you're having massive subcontracting firms work on this. The logistics of working through, between Switzerland, between France, the language barrier, the inspections, and having people live on site, just the complexity of just running a project in
mm,
itself.
yeah. It really was. The level of complexity that we encountered. The amount of integration between the trades that you've got on site, and of course, the inevitable changes that you're going to get. Building these things. I mean, like I say, if you can imagine being inside the Atlas cavern, um, you've got HVAC, to keep the air stable. You've got electricity. You've got very high voltage electricity. You've got dangerous gases. You've got helium. You've got all of these systems. And when you get inside the cavern, and around the experiment, I mean, it literally looks like a bag of snakes. The amount of pipe work. Just in the experiment itself, in the actual detector, there's 3,000 kilometers of cabling, and that's just in the actual experiment itself. So coordination, it really was an absolute priority, and keeping on top of it. Obviously it was a full-time job. It really was. but we'd have a weekly coordination meeting. Between all of the trades and all the physicists and everything else like that. We'd have a once a week meeting, and then that would go away, and then that would be applied to what went on in the cavern. Just one thing was that we had two shafts, so everything had to come down two shafts. One was about 35 feet wide, the other one was about 28 feet wide. So they were at each end of the cavern. Now, when you're lowering anything down the cavern, um, that entire area had to be evacuated because, of course, if something slipped its slings, you've got an object hurtling 400 feet down, and you can only imagine the damage that it would do if it hit something at the bottom. So every time a lift was going on, that entire area had to be evacuated, so that whatever was being brought down or taken away could actually be lifted safely. So that you had to factor those in, and very often to ascend the cavern, depending on the crane speed, that was 30 minutes. So you actually stopped work. If you had two or three of those in a day, you lost an hour and a half, for something that the subcontractors were absolutely not responsible for. So there was this very intricate dance of whose responsibility was things, and costs, and where did it come into. And it was phenomenally complex. The entire project was actually built, would you believe, using Microsoft Project. I mean, that's what we actually used.
For the
That was the
software.
planning. Yeah, that was the planning tool that we had, and within the limits that it's got, it served extremely well. There is an old saying that no plan survives first contact with the enemy, and that was certainly the case at CERN, in that of course you can plan and plan and plan and plan, but once the reality once you get into the reality, then things do change. Things are modified. People don't show up. The usual things that we find on job sites. But it really was a fascinating exercise to watch. It really was very, very, very interesting. Even now, I actually went back just before we came to the US. I went back to visit CERN, because you can do public tours and everything else. Everything's open to the public. You can go and do a tour, and it's funny because like I said earlier, when I was at CERN, I just thought of it as a job. It's you
Yeah.
go on and do your stuff. But it was funny with the hindsight coming back. It was 10 years since I'd left CERN, and we went back, and we drove around the site. We were taken around the site on a bus and so on, and of course, I picked out places where I'd worked, and places where we'd had meetings and stuff like that. It did make me sit back and reflect and go, yeah, I suppose it's a small part of history in that way. It was a funny thing to reflect on. Look, again, with hindsight, and with a few years, it's a funny thing to look at and say, yeah, I was part of building that experiment. So it was it was a funny yeah, it was a funny thing to look back on. It really was.
I love that you touched on that, David, and here's why. I think anyone that's in construction design architecture, um, and really any customer service, right? Customer, forward industry, it's very challenging for a lot of reasons. And in
Yeah.
construction, probably more than a lot of them, because as you mentioned, just the complexity of you managing, and we touched on this, all the different countries and language and inspection barriers, city inspectors in different countries. That's well beyond what most of us are doing on day to day. However, just here locally, Arizona or throughout the country, dealing with suppliers and subcontractors and safety. You touched on this, confined spaces and shoring, right? These are highly dangerous things. It's so stressful. And in our industry, when they talk about, depression and suicide and stress, these are real things in the construction industry. And it's a very trying industry for a lot of reasons.
Mm.
But what's fascinating about that, despite all the uphill battles in a way that we deal with day to day, there's something to be said to go back on something that you've worked on, whether it's a
Yeah.
client's home, whether it's a remodel, whether it's a hotel. I was fortunate to build an awesome hotel, and I went and stayed there with my Builder 20. We
Mm.
came back at Mount Lucia, and it was
Nice.
amazing to go back. And the funny thing is, when you go back 10 years later, like it's fun to see. Yeah, like you said, here's where we had the OAC meetings. Here's where we had these meetings. Here's where I worked on and had these touch points in the project. You may not remember all those nights you went to bed super stressed, David, as you're managing this project, but you can go
Yeah,
back. You said, and I was a part of history. Like I built this. Like
yeah,
any of us that have been to Europe, to go back and see these structures from Rome and Paris that have been here for, you know, 1,000 years, and it's
mm.
just amazing the craftsmanship. So I mean, just I can only imagine how that felt for you to go back 10 years later and visit something that now is being publicly toured, for on a daily basis.
Yeah. Like I say, it was always just a job. While you're there, it's just a job. You're doing your job. But yeah, to actually see it, and and also to see the results. That they, like I said, they were looking for the Higgs boson, and they found the Higgs boson. Which was an incredible achievement. Um, and let's be quite real about this. I was a cog in a very, very large machine. But you like to think that in your own way you made your own contribution to things. And the other thing, Brad, that you do bring up, the health and safety thing is, yeah, this was a phenomenally dangerous project. It really was. When you think about, what we were dealing with, you got open shafts, 400 meters deep, 400 feet deep, working at height, working in confined spaces, working with dangerous gases, working with very, very high amperage, high voltage electricity, you know, night working in tunnels, because the actual accelerator, it's a tunnel. It's about 4 yards wide, 3.8 meters, so it's about 4 yards wide, and we were what we call the cryodipoles. When we were installing those, they actually had, they were basically, you can imagine a tube that's about 15 yards long, and inside that tube is sat what was called the cold mass. And the cold mass was basically a load of laminated steel plates all put together like this that formed part of the magnet that was in there. And these were incredibly delicate because you had to supercool the cold mass. They sat on three composite feet inside. So the whole balancing thing, once this cold mass was slid in and sat on the feet, the whole thing was actually extremely delicate. And we had acceleration values of, it was about I think it was point 3 g in X, Y, and Z. So they had to be moved extremely gently, extremely carefully, and we had to place these in the tunnel, with micrometer precision, because they had to be aligned. They were all aligned by laser, and they had to be transported in the tunnel, and by a machine that was actually built by a German company called Maffei that we designed. It was a prototype machine that we designed between us, because again, it's not very often that you can go down to Home Depot and find a cryodipole magnet moving machine on the shelf. So we built two of these, of course, so if one broke down, and they moved at about, I think that the speed was about a kilometer, about 1.5 kilometers an hour. So all of this work had to be done at night. So you'd got night working, you've got shift working, all this kind of stuff, that added, like you say, added to the potential danger, as well as being, you were down in a tunnel. You could be, at some points you could be a mile and a half from an access point. So if anything happened, you actually had to get them out. And CERN had its own private fire and rescue service, that to deal with any eventualities in the tunnels or on the ground, because it was an international enclave. It actually looked after itself. This is the thing, you couldn't go, the police or the customs couldn't go onto the CERN site without permission. It is. If you imagine, like I say, it's like its own mini country. That's how it worked. It was formed by international treaty. So just those conditions, very, very interesting to work under. Um, and I'd also, I'd worked in the fire and rescue services in the UK. I was a professional firefighter before I went to CERN, and I've seen the flip side of what goes wrong when people don't respect health and safety and stuff like that. We did go to a lot of building accidents, agricultural accidents, road traffic accidents. So when you've seen a bit of that, it does make you realise that you do need to wear the goggles or step back from the edge, or make sure there's barriers in place, and make sure that people are educated and make sure they understand the risks. I believe greatly that it is in education that people need to understand as I used to say, some people have got no imagination, and it's you're standing on the edge of something without a barrier, and it's like just think for a minute what happens if you turn around and lose your balance. Have some imagination. Um, so yeah, I saw enough of that. That's how I actually started building, because I always used to joke that the fire service paid well enough to keep me in building, and we had a on my shift there was an old generation, about a third generation builder, and we used to work 2 days, 2 nights, and then 4 days off. And what we'd do is we'd work 2 days, 2 nights, and then 4 days on a building site. So I learned from a really good traditional old hand builder about building, and that stood me in very good stead, because even today the stuff that I ask guys to do on a job site, it is something that I've actually done myself. I have actually done that. I've been on the tools. I know the difficulties, the shortcomings, and everything else. And I think it's really important in this job that you are a complete person. You to be able to speak to someone with authority and empathy. You've also got to have been in their shoes, and I think that's really important, because, like we said, building it's a staggeringly complex task, and people walk into a home, they don't give it two thoughts, but when you look at the detail that goes into it, and everything else around it, it's a phenomenally complex task, and very gratifying, very frustrating, very annoying, all of those things, that go with it, so, but I absolutely, I love what I do. I love doing it in Arizona. I really do. It's been an absolute, sea change, really, in terms of many, many things in my life. And yeah, what a great place to build. What a great place to build. It really is.
It's interesting because, as you're walking through even your history as first responder, I think what's unique about that project specifically is, I had a very um, significant mentor early on in my career in college, right? And he was a professor, and um, he had an incident where he did a lot of complicated, projects.
Hmm.
Extensive training for all his people, specifically
Yeah.
confined spaces. What goes into not just the PPE, but the protocol if there's an accident or something happens.
Hmm.
Something did happen, and someone went in after him when they shouldn't have. And despite the training, and I think what's really complicated is it's one thing for you to have the safety personnel on site just for your people. It's another thing to train the first responders too, so they understand, the technicality of what they're dealing with to go in after someone if someone gets hurt. But I
Yeah.
think from your side, David, just from an experience side, one thing that I'm curious about is you're working through a project as complicated as this. It's one thing going through the vetting and selection, making sure you have the right subs. From a
Mm.
funding standpoint, you're working, as you mentioned, international treaties, because you're, multi-country here, building CERN. How did that work from funding, from budgets? Who are you accountable for, from a financial side? The funding, how did it take place in general? You may not have all the answers to that, but I'm sure you had some aspect because you're qualifying, bids and lowest bidder to some extent.
Yeah, so it was interesting. So CERN is actually funded by the member states, and that's the European member states. There's two. You've got two distinct groups. You've got the member states, and then you've got observer states. So, for example, the US is actually an observer state at CERN. And what this means is that the US is allowed to contribute very kindly, but they're not allowed to make decisions on the board. You see,
Just
like that.
observe.
Yeah. So, like, for example, you've got the, just trying to think who the observer states are now. I think you've got US, Israel, Turkey. There's quite a few, again, European countries. Canada, I think, as well, is an observer state. So they're allowed to contribute. They send they can send physicists there, engineers who can come and work at CERN and benefit from everything they learn at CERN, but they don't actually get to make the decisions on stuff by sitting on the board. So the member states fund CERN. When I was there every year, the annual funding was, just to run the laboratory, was 980 million Swiss francs. So that's, think more or less parity in terms of dollars, more or less.
Francs are way
That's no
stronger than dollars, though. So
at the moment. At
yeah,
the moment,
yeah,
they were parity recently, but then yeah, it's gone. It's dropped
uh-huh.
again a little bit. But
Right.
so that was the annual budget just for running the laboratory itself, and then of course the funding for the experiment. and the machine, the LHC machine, and then each experiment that was the object of a separate funding. And what happened was uh, basically CERN would every year go to the scientific councils of France, Germany, Switzerland, UK, Italy, and so on, Spain, and they would go and present a budget. And then what happened is each country would contribute in turn what they were able to contribute from the scientific budget. Um, and there was always it's quite as I say funny, but there was always a financial crisis of some sort at CERN. It was always happening. It was always happening. There was always a financial crisis, and um, of course, a massive part of the budget was personnel because so there were about when I started there were about 5,000 staff members, and as a staff member, you've got certain privileges where you're basically classed as an international civil servant. So CERN broadly falls under the group of things like the United Nations, like UNESCO, or it's kind of classed. It's there's about 100 and whatever there are 140 of these international organisations in Geneva. Um, so that's where the funding came from, and then it would have been about 2000. I think it was about 2003. I think it was. There was this huge crisis with the funding. They weren't sure they were going to be able to complete the LHC and so on. I mean, of course they did because the funding was made available, but they offered personnel. If you took a percentage cut in salary, then you'd get extra holidays. So you get an extra day extra day or extra 2 days. And then if you took, they called them slices. So then if you took 3 slices, they then give you another day on top of that. And they realized that this was actually hugely successful, a bit too successful. So they stopped doing it because people were actually taking too much time off. They were willing to give up a portion of their pay, to have a bit more time off. So that was they stopped doing that in the end. But like I say, there was always a funding crisis of some description at CERN. They reduced the personnel. I think there's only about 2,000 staff members, and they did that just through natural wastage. People retiring, people coming to the end of contracts, and so on. So that was that. And then it was very interesting because you were dealing with highly theoretical individuals. So, we were dealing with particle physicists who, incredibly intelligent in their field. Of course, that's why they're at CERN. They really are at the top of their game. But you have to realize that they're there because they want to do particle physics. They're not interested in engineering and civil engineering and how other things work. All they want to do is smash particles together and see what comes off, in a very simple term. So we had a project manager he was a physicist who ran the Atlas experiment, and again, phenomenal scientist, phenomenal physicist, but he would pull numbers out of hats. He would say, okay, I'm going to allocate 3 million Swiss francs for all of the exceptional transports, because what happened was components of the experiment were built all over the CERN site, and we had to move these, and then we assembled them in the hall before they were lowered down into the pit. So we had to move them. We had a very very good old established company called Frederici, which is a Swiss transport company, and they had multi-axle trailers. These things could orient themselves in X, Y, and Z. I mean, phenomenal pieces of kit. But usually you would go to the company and say, okay, we need to move this 280 ton, 14 meter high object. How much is that going to cost? Rather than just saying, well, I'm going to allocate 3 million for all of the exceptional transports that we've got to do over 3 years. So, there was a lot of, how can you say it? Yeah, there was a lot of explaining that had to be done. And, like I said, these guys were at the top of their game. Their egos didn't often allow them to listen very well to mere minions, and so there was a lot of conjuring that had to go on with these kind of things, and yeah, it was interesting. You had to fight for your allocation of funding to do a lot of stuff, and it was silly because that was always what it was going to cost. No one was putting money in their own pocket here. It was going to cost 250,000 to move this object from here to here. Where if you thought it was going to cost $50,000, well, you were very wrong. It was always going to cost $250,000. So, there was it was kind of sometimes putting the cart before the horse, and you had to reverse that and unravel it. And yeah, that absorbed quite a lot of energy actually doing that kind of stuff. It really did. It was quite interesting.
So let me ask you this, David. I mean, you have this incredible experience. You're building one of the most amazing structures in the world, right? That's so well renowned. What brings you from there to here, Arizona? Back to the U.S.
So good question. Yeah, I've been living in Switzerland. I lived in France for 15 years, and I moved into Switzerland. I met my now wife Victoria, and
Where are you
I've lived
from
in.
originally, if you don't mind me
I'm
asking?
from the UK. Yeah, no, I'm from the UK. I'm
Yeah,
from a
okay.
place called Staffordshire, which is it's right in the geographic center of the UK.
Okay.
It was world famous for. You might have heard of the names like Wedgwood and Spode pottery, very very fine bone
Mhm.
china. It was a world center for that, and then that all went south about 30 years ago now. And then the coal, it was renowned for coal mining and also for steel. So those are the three industries in the town. And they all died within about sort of 15 years of each other, and now it's unfortunately it's a city that's in post-industrial decline. Very sad. I was back there last year, and it was truly very sad to see.
It's tough.
um, yeah, just how it's gone. I mean, it was a thriving blue collar town when I was growing up, and to see it now, it's a very very sorry state. But yeah, I left the UK in '96, moved to France, worked in Switzerland at CERN, spent 9 years at CERN, and then um, I'd my I'd kind of my time had sort of expired there. I'd had a fantastic time. I moved there. I loved alpine climbing, ice climbing,
Mhm.
skiing, hang gliding. I did all these ridiculous things and managed not to kill myself. Um, and it was an amazing time, Brad. But there also comes a time when you're doing stuff like that you do realize that yeah, there's a time limit on that. There's an expiry date on doing this kind of thing, because and it happened to me. It was a very 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 clear cut thing. I was on a climb that I'd done a few times in the Alps. We were up at about 12,500 feet with a friend. We were traversing a long ridge, and I had this very clear cut moment of like, yeah, I don't want to be here anymore. I had this. It was a very very clear cut thing, and you often had this if you're out on an alpine route and it was all going wrong. And, you were like, yeah, I'm getting home. I'm selling all my stuff. I'm fed up with this. This is stupid. What a stupid activity. And then you get back home and you reflect on it about a week later, and you go like, oh, that was really cool. But I had this very clear cut moment, and I thought, yeah, it'll pass, and it didn't. I was like, no, I'm not quite as fit as I used to be. I don't see quite as well as I used to. I don't have quite the same reactions. And I thought, yeah, if you slip up here, you're falling for the rest of your life. So, it was time to sort of shelve that and take that as a very good experience. So I've been coming to Arizona since 2005, and I actually went horse riding down in Tucson, at the Tanque Verde Ranch. And there was always this thing that you come in from London on the 747. It's
Yep.
5:30 on the afternoon. Everyone's seen it flying over in Phoenix,
Yep.
and I always had this thing that you'd look out at Phoenix in the area, and it was like there's so much opportunity here. It was just it was a feeling that I had, and I started coming back. I just got really interested in the place, because most people in the UK or Europe, you say Phoenix, and they're like, well, where's that? Because everyone knows East and West
Yeah.
Coast.
Yeah.
That's what everyone knows. And that was it. Always got me. Like I say, you'd fly in, and you're jet lagged. It's like in your head, it's 3 a.m. in the morning. But like you'd look out and you'd just see the sun setting, and you used to be like, wow, there's something going on here that's really good. So that stayed with me, and I would come back every year, and I'd always end up in Phoenix for some reason. We'd travel around, but like we'd always either come in and out of Phoenix, or we'd pass through. And it really, yeah, it just intrigued me. So that was 2006. I'd sort of had a plan of coming over in about 2009, but of course that was absolutely not the time to get into anything related to construction
Mhm.
with the with how the market was and everything else. It was bad. It was bad everywhere. So I stuck where I was in Switzerland because Switzerland was ironically one of the only countries in the world where salaries went up during the downturn. So it was a good place to be. And Switzerland had an interesting, because people are so transient especially in Geneva. Houses are coming and going all the time. People want them turned over. People want them to be renovated, remodeled. How they want their house to look. So there was a never ending supply of work to do in that respect. But like I say, it was time to move on. I got a bit fed up with being cold because it used to start in Geneva around September time, and then you often got snow down, obviously over winter, and it didn't really warm up until about April time, and then the winter, the summer was quite short, so it was quite a short period. And yeah, I wanted something a little bit more stable in terms of weather and stuff like that. So I started making a plan. In the meantime, I met Victoria, my long suffering and hugely tolerant wife, um, and we started. We talked about this, and we started putting a plan together. And yeah, 2000. I remember we sat down in a cafe. We'd walked our dog, who's sadly no longer with us, but we'd walked him and we were having a cup of hot chocolate, and we looked at each other and we said, "So we're doing this, right?" And we said, "Yeah, okay." So of course, then we put in process the whole. You've got to put into the whole thing with visas and everything else, which is
Yep.
a long process in itself. And so that took 12 months. We had to wind everything down in Switzerland while still ramping things up in the US. And we moved over in it was end of February 2017 and hit the ground running. And that was yeah that was how it started. But yeah, I was always fascinated by Arizona. I loved. I first passed through the state in 1991. I worked on a summer camp up in New York State. There's something called Camp America in the UK, and what it is, it's what's called the J1 Cultural Exchange Visa. So you could come to the US and you could work in sort of an education type way, if you like. So I worked on a scout camp, and we were teaching kids all sorts of things like pioneering, sort of like knot tying and building shelters and all this kind of stuff. And it was absolutely fantastic experience. I mean, it was just brilliant, Brad. I can't express how good it was. I was 20 years old, and what Camp America did was they flew you over to the US, and then you were fed and housed on the camp while you worked there, and then you would what happened is that they would then let you loose after the camp, and they gave you, I think, what was it eight, what did I have, $800 spending money. That's right, $800 you were given for sort of six weeks. Yeah, 6 weeks we were on the camp, and that you were given an allowance of $800 it was. And then they let you loose, and then they would pay your return flight back to the UK. So, and you could choose when you flew back. So, we traveled across the US, and we took the Amtrak, which was $299 for 45 days unlimited rail travel. And we basically did, East Coast to West up to San Francisco, and then all the way back through New Orleans and places like that. So that was my first, that was my first experience in the US. And I didn't come back until 2005. And that was, first of all, it was with a friend, a school friend who's I'm still in regular contact with, and he's a very good photographer, and he always used to have a week away from his family, and he'd just go off and do photography. And we were chatting, and he said, "Yeah," he said, "I'm off to the US. I want to go and do the Southwest and areas like that, and I'm going to go and do this and that." And then he looked. He said, "Do you want to come along?" And I said, "Yeah, great. Fantastic idea." So we put all that together, and it was. I came back, and I was like, why have I not come back for so long? And again, it's one of these realization things that you just think, what the heck was I doing not coming back to the US? So that was when I came back and again, like I say, went horse riding. So this looks like fun, and then then it just ran from there. And yeah, that's kind of how how I ended up in Arizona. So yeah.
That's amazing. And now being here, why tell us, scope of work, your specialty, what you focus on.
Yeah, so we came into the market initially, doing renovations and remodels. That was where we started out. We had initially we had a showroom in the Scottsdale Quarter. We had a kitchen showroom in there, and that lasted about 18 months. It was a good location and a not so good location because you certainly got the foot traffic, but you didn't really get the foot traffic that were genuinely interested. So many people
Yeah.
came in. We ran it as a kitchen showroom, and then we also ran it as a gallery. My wife's an artist, so she actually rallied a lot of local Arizona artists, and they came and displayed their work on the walls. So it had a very really good feel to it. There was a lot of artwork there and everything else. And we realized that yes, it was a good direction, but it still wasn't ultimately, it wasn't just pure going out renovating and remodeling. So we let that go, and we moved back. We moved back into, if you like, we moved into just renovations and remodels, and that really took off. I think we caught the market. We caught the market well. We also networked like there was no tomorrow. And that did pay dividends. And it's one of the things I love about the US, that everyone's up for networking. It's all about going out, meeting and greeting and speaking and exchanging information and seeing what you can do. And I love that. It's great. So speaking to people is not is it's never been a problem, but it was really good. And that ran really well, and continues to run well, that side of the business. But it was during pandemic, I really got interested in the wine rooms. We'd done a few properties where we had either seen them, or we'd actually built them, or we'd been part of building them. And it just it really intrigued me, because living in France, I'd spent many hours visiting the cave, what they call them, cave in France, which is this structure that's built underground, very often 200-300 years old, where they'd store the wine to age them. So, and there's a feeling about walking into these places. It's very interesting. You go down the steps, and however hot it is outside, because you could get up towards late 90s in where I was in summer, but there was always this coolness that just enveloped you. It was a fascinating feeling, that when you just went in, there was just this coolness that surrounded you in these caves. So I always liked, I always loved that thing. And of course, they were often built in natural stone, and they were just fascinating places. So I got into the technical side of things, and because I really enjoy the technicality of wine rooms. You've got to get them right. There's People look on them as, oh, they're just like an insulated box or something like that, and it's not the case. There's a lot to them, and as you can imagine, the consequences of getting a wine room wrong, where you might have 500 or 600 bottles of some very expensive wine, and then having them either ruined or pushing the corks out or something like that, it doesn't bear thinking about. So you've really got to get these things right. And I love, like I say, I love, I'm pretty well versed on insulation because of what I did at CERN. I'm well versed in cooling because of what I did at CERN, and just that thing of detail, just building them up, making them very individual. And that is what I love. Every wine cellar that we've done, uh, we've never done two the same, and it's never my intention to do two wine cellars the same. Each one is, it's bespoke, it is crafted towards the client and the house, and that's half the fun for me, is actually matching the product to the client and to the house. And it's very that's very rewarding, to get that right. It really is. So I do, yeah, I really find them a challenge in a very nice way, just to get them right. So yeah, plenty of fun to be had with those.
And you feel good. Business has grown. It takes time to build any business, but projections are good.
Yeah, things are going well. We hit the ground running back in 2017, and things have grown steadily. I'm very much a fan of letting things grow, not pushing the growth too much, but growing at a rate that you can manage properly and carefully, because there's a lot of expectations riding on what you do, what you turn out. There's a hell of a lot of stuff riding on that, and I think it's very important that there can be the temptation, especially in construction, there can be the temptation to grow very, very quickly. And if you are not organized and you don't have the resources, and you don't have the systems in place, then things can go south very, 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 very quickly and very badly. So, I'm a great believer in letting things grow and develop, and that was what the wine rooms came out of that scenario, if you like. That I was ready to move on and expand and do something as well as what we were doing with the renovation and so on. And I wanted a product as well. I wanted to actually create a product. I always look on renovation and remodeling as a service, but then I actually wanted to create a product, and that was when the wine rooms came in. That's how it sort of fits into the business model.
David, it's been amazing. And the funny thing is, I think we probably had about 20 items to get to. We got through one. Well, maybe two. We got through CERN, and we got through, the business and, essentially a relocation here to Arizona. But I want to be gracious of your time as well. So for those listening, you've been an incredible guest. I mean, the knowledge, I'm so fascinated with your career and what you've done. And we're going to have to, I think, bring you back for another episode here for the audience. But,
Oh, I can talk for England, Brad. So don't worry about that. Yeah, always happy to help out. That's the thing. But listen, thanks very much for having me on. It's been an absolute pleasure. It really has. Great to speak to you.
Yeah, and David, for those listening, please, leave all your info. Where can they find you?
Yeah, so we're on cncscottsdale.com. That's our website. And then you've got exquisitewinecellars.com as well. And we can be reached through those. We're also on Instagram, Create and Construct Scottsdale. And we're also on Exquisite Wine Cellars as well. So you can find us through those two means quite easily. And I'm always available, always happy to chat. So, yeah.
Well, David, you've been amazing. Thank you again for making time.
Thanks again, Brad. Great to speak to you. Thank you very much.
If you get value from the show, please support us by giving a 5-star rating and review on whatever platform you listen to. And I also have a favor to ask. We've had some incredible guests that come on and share their wisdom, their knowledge about their business. So if you have friends or family members that could benefit from those episodes, please share it with them, as well as any other business owners that you're networking with that could get value from the podcast or certain episodes. Please share those as well. Again, subscribe, make sure you're following. Any questions that you have, topics. We've had listeners reach out about certain guests that we should have on the show. Again, brad.l@aftconstruction.com. Email me for topics to address, guests that we should have on, and even if you think you'd be a great guest for the show. So again, thank you for all your support, and we'll see you next time.